Okay, so now I'm going to talk about number 3 of the calc section. I think many people miss this problem and probably making up this problem, so I'll make sure I do a good job with this one. So when you have to find initial velocity, one thing to keep in mind is that this right here represents a vertex. So if I were to graph this, we expect the trajectory to be like this because we do have a parabola with a negative leading coefficient, so it's going to open down. And x is time, you're told that, and y is height, you're told that as well. So the maximum is where the vertex is. And because it happens at 2.5 seconds, the x-coordinate of the vertex is 2.5. We also know the x-coordinate vertex is negative b over 2a. Looking at the equation, we don't know what b is, but notice how b is in v's position. Sorry, v is in v's position. So negative v, and a is negative 16, right? So that's v over 32. So we just connect these two together, and we got our velocity. Really not too bad. So v equals 80. So now your equation is this, for part B. And by the way, for the makeup problem for this one, I'm not going to ask you to find a velocity, I'll just give you the equation. So basically it'll be like parts B, C, and D. So here we have an equation. To find the maximum height, you can either plug in 2.5, or what you can do is use a graphing calculator. So when you do the graphing calculator, we get something kind of like this. And your window should be the following. X min, I'll probably do 0. X max, we'll probably say 10 seconds. Y min, we'll say 0. Y max, we'll say 200, because this ball might go kind of high. So when I work this out in the calculator, and if I graph it correctly, I wish I could show it to you, you should be able to find the maximum by going to second, trace, option 4. It's going to ask for a left boundary, so move to the left. It's going to ask for a right boundary, move to the right. Ask for a guess, so hit enter. And if I do it here real fast, just got to be a little bit patient. Left, right, hit enter again. Say 2.5 comma 104. So the maximum height is obviously 104. When is it 10 feet above the ground? So you're going to graph two equations. Obviously you still graph the parabola as y1, but you must also graph y equals 10 and find the point or points of intersection. That'll be under second trace, option 5. And just move the cursor close to one of them and hit enter 3 times. 1, 2, 3. So this one here should be 4.92 if we round to 2 decimal places. And the other one if I move close to that point of intersection, 1, 2, 3, I should get 0.08 seconds. Okay, last one, part D. How long does the ball stay in the air before it hits the ground? So we assume it was 5, but we can't assume that because it starts at an initial height of 4. If you were plugging 0 for x into your equation, you'd see that Vy equals 4. So we can't assume it's just 5. What you need to do is set your equation equal to 0. And use quad form. You can also use the zeros feature. If you do zeros, that would be second trace option 2. But if I use quad form, really simple. We have 16, 80, and 4. We get negative 0.05, which is obviously not true, or 5.05 seconds. So that's how you do number 3 of the calc sector. So do expect a problem very close to that, like B, C, and D, on the makeup. Okay, that's it.